Okay, now we're going to get into more detail about Grignard reactions and specifically things we can and can't do with them in synthesis problems. So before you start, you might want to go on Canvas and print out the worksheet that says Grignard reactions and protecting groups. And we're going to work through these problems as we write out our notes. So first, let's review how Grignard reactions work. We did this a couple days ago, but just to refresh our memory, a Grignard reagent adds to a carbonyl compound. So if you have an aldehyde or ketone, there's no good leaving group on there. So the Grignard reagent is going to only add once. And I'm not going to write out the full mechanism here because we've done this before, but basically the R group attached to the magnesium, this carbon has a partial minus, or even you could think of it as a full minus charge. So it's a great nucleophile. It comes in and it attacks that carbon that has a partial plus charge. The nucleophile attacks electrophile, kicks up electrons, and then when we add the water, that oxygen gets protonated to give us an alcohol. So the whole point here is that an alcohol is going to be the final product, and the Grignard reagent that we're adding is going to add once. Adds one time. If instead we do a Grignard reaction on an ester or an acid chloride, then what happens, the difference is that we have a good leaving group on our reagent. And so we're going to start out the same way in the mechanism. That nucleophile from our Grignard reagent is going to attack that partial plus carbon. Electrons are going to kick up, but then they're going to kick down and kick out the leaving group. And then we have an aldehyde or a ketone, and the same thing can happen again. So the end result of all of these steps in the mechanism was that we're going to end up with an alcohol, but that Grignard reagent that we're adding adds twice. Adds 2 times, which was the case for people who made malachite green in the lab. And in fact, if we have another leaving group on here, like people who made crystal violet in lab, then the Grignard could actually add 3 times, although that's not as common to have a double ester like that. Okay, so these are the main 2 reactions, and in synthesis problems, we more often use reactions where the Grignard adds once. Unless you have some sort of symmetry in your molecule, you're probably not going to want your Grignard reagent to add twice. Let's start off by practicing the mechanism. We'll do number 1 on the worksheet. So at this point, you might want to pause the video, try this problem on your own, and then turn it back on to see if you have the right answer. But I'm going to clear the screen here and write up this problem. So this is number 1 on the worksheet that says Grignard reactions and protecting groups. And we're given this ester. And we're asked to show the mechanism and predict the major product in this reaction. And our Grignard reagent is a methyl Grignard, CH3MgBr. So in our mechanism, I'm going to turn that into a dot dot minus charge. The magnesium, remember, is the plus charge. That's just a counter ion. And we have this partial plus carbon at the carbonyl. So it's going to attack there and kick electrons up. So the first step in my mechanism is that I make an O dot dot minus. I've now attached a methyl group, and I still have this ring here. But remember that this is an ester, and as we just reviewed, this is a good leaving group. So the carbonyl is going to reform, and it's going to kick out that leaving group. And so the next step in my mechanism is that I actually have a ketone, and then I have an O dot dot minus, and this guy is just going to hang around. It's going to have a magnesium counter ion, but nothing's going to happen to it until the end when we add water. But now I have a ketone here sitting in the presence of some really strong nucleophile. So my Grignard reagent is again going to attack the alpha carbon, and it's going to kick electrons up to the oxygen again. So now I've added not just one, but two methyls. And at this point, I have two oxygens with minus charges on them, and there would be MgBr counter ions next to each. If you want to draw them in, you can, but you don't have to. And then the reagent just sits here and does nothing. There's no more leaving group to kick out. So nothing will happen until you add water to quench the reaction. And I'm going to write two water molecules here because each of these oxygen atoms is going to get protonated by a different water molecule. And so the final product at the end of this whole thing looks like this. We have a diol, two oxygens, two OH groups. 1, 2, 3, 4, 1, 2, 3, 4. Okay, so that's our mechanism in our final product. Okay, number 2 on the worksheet is a good reaction to think about how you kind of think backwards in a synthesis problem to use a Grignard reagent. So number 2 on the worksheet says, show how you would synthesize the following molecule. And we've got this alcohol. And we want to use a Grignard reagent. It says that more than one answer is possible. So this would be a good point to pause the video and see how many different answers you can come up with on your own before I go over this. Okay, so hopefully you've had a chance to try this on your own. But one thing you want to think about is at the end of a Grignard reaction, you always end up with an alcohol on what used to be that alpha carbon of the carbonyl. So as you're thinking backwards in this reaction, remember my retrosynthetic arrows? This bond, this single bond to the OH group, is probably going to be, or originally was, a double bond to an oxygen. And then the Grignard reagent that I added could have been any of these three groups that are attached here. I'm just looking to see if I just right. I think I put an extra methyl here. Okay, so the Grignard reagent that I added, it could have been this vinyl group here. Let's say that it was the vinyl group. Then that means that I want to start with two methyls on my carbonyl carbon. And then my vinyl group here, this should originally be a Grignard reagent. So in that case, I would have reacted it with something that looks like MgBr, and then that's got to be attached to those two carbons. Okay, now the question said that I just need to do this starting with a Grignard reaction. So I don't have to show how I make the Grignard reagent, I just have to show the forward reaction. So once I piece it all together, then I would just write the forward reaction. I would say something like this. Here's my Grignard reagent. First, I would add my carbonyl compound. We decided it would be this. This is actually acetone. And then as a second step, you always have to add water to quench your Grignard reaction. Okay, so that would give us this compound. Okay, that is one of at least two possible answers here. Another way that we could think about this problem, and I'm going to erase this work now and go back and think about where I could have divided this molecule. So another way I could have thought about this is, well, instead of this piece being my Grignard reagent, maybe it's one of the methyls. So if I think backwards, that means that my carbonyl compound would have had a methyl and a vinyl group on it. And that means my Grignard reagent would just be a methyl. So my Grignard reagent I would have to use would be CH3MgBr. So in the forward direction, if I were writing this, I would write something like CH3MgBr. I'm going to react it first with this ketone. And then second, I'm going to add water to quench the reaction. So that's a second possible answer that would work in this problem. The third way that you could do this problem is to notice that there are actually two methyl groups. There are two identical groups on this carbon that the oxygen is attached to. So we know that Grignards add twice to esters. What if we start with an ester and we use a Grignard reagent that's going to add twice? So the third possible answer that I could come up with, if I'm thinking backwards again, would be to start with a carbonyl compound that's actually an ester. Okay, so it has to have this vinyl group attached to it. And then you can put any ester on here you want, or you could make it an acid chloride. An ester is probably safer to work with, so just a methyl ester would work there. And then my Grignard reagent would be CH3MGBr. I need a methyl Grignard because I'm adding a methyl group twice. So in the forward direction, I might write something like this. Here's my ester. And then I'm going to add excess of this methyl magnesium bromide. And then I'll work the reaction up with water. And so there, that little piece that I added to make an ester just gets kicked off as a leaving group. So that is the third possible answer in this problem. Okay, that's a good stopping point.